predict the products and mention the mechanism. Now I am going to explain each and every reactions with the mechanism. When this compound, it's a alkyl halide, reacts with sodium cyanide in presence of DMSO. DMSO means dimethyl sulfoxide. It's using as a solvent. Which product we are getting? DMSO is a polar aprotic solvent. And sodium cyanide, the Cn minus, act as a nucleophile. When this carbon-bromine bond breaks, we get CH3, CH2, carbon methyl and one hydrogen. So here carbocation. So here we are getting 2-degree carbocation. So 2-degree carbocation means the reaction will undergo SN2 reaction. So that means it is a concerted process. Carbon-bromine bond breaks and nucleophile attacks happens together. Now we can draw the transition state of SN2 reaction. Carbon, this is a methyl. Now here dot dot Br means Br is leaving, and here dot dot Cn minus means Cn is adding. So this is your transition state. This is at this step only. So final product will be CH3, CH2, this is the final product which follows SN2 mechanism. Next reaction is when tertiary butyl chloride reacts with sodium methane thiolate. What is going to happen? Now sodium methane thiolate, it's an ionic compound, so it is a Na plus and HCH3 minus. So HCH3 minus, this HCH3 minus act as a nucleophile. Tertiary butyl chloride, when the carbon chlorine bond breaks, we get 3-degree carbocation. And we know that 3-degree carbocation is a very stable carbocation. So that means it undergoes SN1 mechanism. So now we are getting a 3-degree carbocation. So this is at this step. The next step is where the nucleophile attacks to the carbocation and we are getting the final product. So that means reaction mechanism is SN1. Since it is a SN1 mechanism, so we have to use a polar protic solvent. And water is a polar protic solvent, so we are using a polar protic solvent for SN1 reaction. Next reaction, when this iodo compound is treated with acidic water. Now let's see what is happening. First carbon iodine bond breaks. We get a secondary carbocation. This is a 2-degree carbocation, so it will undergo SN2 mechanism. Here H2 is acting as a nucleophile. So it will proceed by SN2, so we have to draw the transition state first. CH3, carbon, hydrogen, this side it's a ethyl. Dot dot I means iodine is leaving and dot dot OH2 means nucleophile is attacking. So this is transition state. Now product is CH3, CH, oxygen will be positively charged and then CH2, CH3. Last step is the deprotonation, and due to deprotonation we will be getting alcohol. So this reaction also follows SN2 mechanism. In this reaction, water also can act as a base, though it is not a very strong base, but still elimination reaction is possible. So when carbon iodine bond break, we get a 2-degree carbocation. Now deprotonation can take place because here beta hydrogens are present. So this is beta hydrogen, this is also beta hydrogen. So that means there are two types of beta hydrogen. When the left hand side beta hydrogen elimination takes place, we get CH2 double bond carbon hydrogen CH2 CH3. When the right hand side beta hydrogen takes place, beta hydrogen elimination takes place, that time we get CH3 carbon, here double bond carbon hydrogen CH3. That means we are getting two types of alkene. Now B alkene will be major product because it is more stable than A. If we consider the hyperconjugation, we can see that with respect to this carbon-carbon double bond, there are 2 alpha carbons and 2 alpha carbons has 6 alpha hydrogens, so 6 hyperconjugation structure. Similarly, in the compound A, this is your alkene part. Now you have only 1 alpha carbons. 1 alpha carbons has 2 alpha hydrogens, so 2 hyperconjugation structures are possible. So that means compound B is more stable than A, so compound B will be the major product. And this mechanism follows E2 mechanism because here we are getting 2-degree carbocation.